I have a question for the panelists. We have spoken a lot on SAF and hydrogen, and there is a question, I think it's not sufficiently addressed, is the possible competition, I don't know if it's a correct qualification, between hydrogen used as a fuel in the aircraft and on the other hand, hydrogen used to make e-fuels or power to liquid, it is called, resulting from a combination of hydrogen produced by electrolysis of water with renewable electricity and CO2 captures. So I have a question for the panelists. How do you see this competition? Is it really a competition? And how do you see the milestone that we will have in the future to select one or one of these two options? Are there two options or not? I don't know who want to answer about these two options we have in front of us.
Maybe. Yeah, and I'll try to be to keep it short.
Okay.
We don't believe there's a competition. It's clear that SAFs and power to liquid, means e-fuels, synthetic fuels derived from hydrogen, are an important part of our industry action plan. And it's clear that when we don't make it all with SAFs, we can think of e-fuels. So that's a part. And by the way, back to what was said a minute ago, with the volume issue of hydrogen, there's no intention, at least initially, to go that far with hydrogen. So the solution for the mid-long range is a solution based on drop-in, and drop-in is SAF or PTL. PTL being dependent on hydrogen. Then we have to look at the other side, which is that these solutions still have a CO2 footprint,
okay.
And to a certain extent, there is also a NOx footprint. So the question of mastering the overall impact on the environment is on the table, and we do believe hydrogen not only is less energy consuming in its production, because you need more energy still to go from hydrogen to synthetic fuel, but has potentially less emissions. So it's very important to follow both tracks in parallel. In French, we say cheese and dessert, which is our classical. I mean, we are missing restaurants at the moment, so
yes.
sorry to talk about food. But we truly believe we must follow both, and there will be a nice complement. But it's not one cannot exist without the other.
Okay, so Paul wanted to also to give an answer.
Yes, I think we can also have our cheese and dessert, like Jean-Brice. I think we mustn't view aviation in a bubble. There is a massive hydrogen economy that is growing outside of aviation, and I believe we'll see hydrogen in home heating, in point-to-point transport like trucks, trains, and buses. And so really what I believe is it's going to come down to an economic battle, more so than an environmental battle. The fact is that the pathway from hydrogen into aviation fuel, it costs money. We're going to end up with a product that costs more than jet fuel and costs more than hydrogen. To offset that, we're using existing technology. We can fly the aircraft further, and there are other benefits. So I believe it is going to be a dessert and cheese, but where the balance is between hydrogen and SAFs is going to land from economics and also time to maturity. I think the other thing that we must bear in mind is we've all signed up to get to net zero by 2050. So any technologies that mature beyond 2050 don't help that race. And if we're going to limit global warming to 1.5 degrees and aviation to do its bit, we've got to get there by 2050.
Thank you. So now we go through the question and answers coming from the audience. So with a jingle, so it should come. Vous le voyez, vous, le jingle? Okay, so we have some questions coming from the audience, and the first one. So I have to translate because it's in French. Some people believe that synthetic fuel could be the solution. Let's say, so we solve the problem with synthetic fuel, and so we could have some. So the question is, what would justify the use in parallel to SAF, if they become available at the sufficient scale, of electricity, which could be limited to short range, or hydrogen. Once you have SAF, some people say, oh, you have solved the problem of aviation. So what is your answer to this? Paul, okay. So we don't hear you. We don't hear you.
Yeah, sorry. I said I passed to Rolf first because he hasn't spoken yet.
Okay, Rolf.
Yeah, that's a really good question because what I said, for all the direct hydrogen application, whether it's fuel cells, even more complicated, or even for direct burn, where we need the tanks, the infrastructure, everything else. So the question is really, why would anybody do that and change a whole aircraft architecture, the aviation architecture? If there's any society saying we don't want any more carbon-based fuel in the air, then we have to use hydrogen. If this is not the case, I think really that we can go for carbon neutral, climate neutral, environmentally neutral applications with SAF and with the other applications. So the really question is, what will be the requirements for the future? And as we don't know it today, we better be prepared.
Paul?
So I'm going to make a different point because I agree with Rolf's point. In smaller aircraft, electrification, hybrid electric, and hydrogen with fuel cells has another trick up its sleeve, and that's a whole new type of aircraft. It's a great time for aviation. We can come up with new ways of moving people vertically, things like the city Airbus concept. We can come up with very quiet city hopper aircraft based on pure electric flight. So we have to think somehow beyond the net zero agenda into new types of aircraft that will excite people in new ways.
Stefan?
Yeah, so I agree with both statements. So really, there are two different worlds. Small segments, new types of mobilities where really between electricity and hydrogen, we can go to really new avenues. On larger aircraft, the question really is about can we make the target with SAF and PTL only? If we can, we'll see. There will be less interest to go to hydrogen. But if there is a question of net zero, is net zero acceptable? Must it be zero emission in flight? Then hydrogen is necessary. And another question is the non-CO2 impact. So let's be clear, CO2 is the top priority due to the cumulative impact of CO2, but we'll have to deal with non-CO2 impact too. And we need to understand, so we know SAF are likely to have a beneficial impact, especially on contrails. We need to understand better what is the extent. And on H2, we need to understand the effect too. So we assume that there will be maybe more contrails, but of a different nature. But we don't know exactly what will be the net result. And so research is needed to see if there is a strong benefit for non-CO2 effect. So it's a lot about availability, acceptability of variant strategy, net zero or full zero, and also the non-CO2 effects on top.
Okay, thank you. So we have another question regarding engineering aspects of liquid hydrogen aircraft. The question is, do exist in, let's say in Airbus and Boeing, a pre-design of liquid hydrogen aircraft, which seems reasonable in terms of size, mass, volume, or is it still ongoing at the moment? So it's a question for Airbus and Boeing, but others can answer, of course.
So
Sheila,
I'll go ahead
Sheila,
first. So in terms of looking at it, I think we continue to look at it. Like I've mentioned, we have flown and understand a little bit more about the liquid hydrogen and the application. It's, again, as we stated in the whole hydrogen conversation, it's something that has to be explored. There is a lot of the infrastructure that needs to be better understood, because you're not only changing the type of fuel, so you're changing the airports, you're changing every airport in order for you to, global transportation, you need to arrive and know that you can fuel your airplane too. So it's about the airplane, it's about the airport, it's about the full infrastructure. So I think it's broader than just understanding how liquid hydrogen works in the airplane. And so we're continuing to look at it from a systems view. Because the technical part we need to continue to explore and understand further. So again, it's this whole climate change dynamic requires us to look at a lot of solutions. I don't think we have the luxury of looking at only one, but there's the near-term solution that we've talked a lot about in terms of SAF, and then we need to continue the exploration.
Jean-Brice, no, you.
Yeah, maybe to complement it, I think when we say we want to bring an aircraft, a zero-emission aircraft into service not later than 2035, it's not an ad. I mean, we are serious about it. So we are indeed running pre-design work. The difficulties that were rightly listed from Ariane are I think the right list of challenges we need to address for the aircraft. And then there's indeed a grid story. There is a question of supply. There's a question of infrastructure at the airport. And as we don't want to develop an aircraft that has no available fuel at airports, we're also looking at the technologies and the evolutions we need to promote at and around airports. Back to the aircraft. Yes, of course, we are looking at what kind of technologies we can have for our fuel tanks, for our pipes. We need to have the hydrogen gaseous when coming into the engine. So all of this is what we are looking at, and we have a roadmap to get to the right technology readiness level and to be able to launch the development when the stars are aligned. And we do believe that we must do the technology work, which, by the way, was said by most of the other participants. That's what we have ahead of us. We must do this technology work, and we must not answer questions too early. And I think the points like hydrogen is not a way, or we could be only with synthetic fuels, these are too early answers. We can't afford closing doors. We have to let the ways open. And now back to Airbus. Indeed, yes, we are active to reach a point in, let's say, 2024, notionally, when we can decide what type of aircraft, what architecture, what technologies we would choose. And then there's a question of explain. There's a question of a wider demonstration that Rolf touched on a few minutes ago. That would be the preparation for ultimately a program.
Okay, Stéphane, you wanted to add something. Yes.
Yeah, maybe to answer the question, and again, I don't know the details of the studies performed by Airbus and Boeing. Some of them were published in the past by Airbus in European programs, but we've done some studies too. And to the question, it's not an energetic problem. We know that batteries-powered aircraft, they don't fly for the short, medium range type of aircraft. So that's physically impossible. For hydrogen, you can design an aircraft which flies a very decent range. So that's not the question. We know it's feasible energetically. Now, the question is more all the difficulties around the technologies to be developed and which needs to be mature around handling the fuel, feeding the engines, ensuring safety, temperatures, and so these are an infrastructure. These are the difficulties. But unlike electrical propulsion, we don't have an energy problem, which is very different. So it's good to note it too.
Okay, so I will have a final question for all of you. just to mention that we have probably more than 1,000 people connected, and a lot of young people are hearing you. And as you know, in France, a recent report has been released by a think tank, the Shift Project, and an association of students, Super Héros des Carbos. So for all of you, I will simplify saying that they consider a global carbon budget for the humanity for the remaining years, for up to 2050, and they allocate a specific carbon budget to each sector in proportion to the emission of this sector. So it means for aviation, air transport, 2.56% of budget of carbon, which can be spent up to 2050, and so it means a small portion of this budget. So how do you analyze the conclusion of this report, saying that, and they put forward the necessity for air transport to decrease in the coming years in order to comply with this scenario of which is linked to a scenario of the limited temperature elevation. What would you say to the young generation to promote that we are as industry, as research establishment, we are really on a route to propose new solutions, disruptive solutions that could really answer to the environmental challenges we have? Because a lot of the young people are really sensitive to it, and they really think that the air transport has to decrease in the future. So what would you answer to them? I see. Stefan,
I may start because I've read the full report.
Yes, I know.
I know. And I must say it's a good work in terms of modeling, asking the right questions. So I support this type of serious work, but I disagree with the conclusions. And basically, the message is that they build two scenarios. One is called Maverick, and it's the type of scenario we are working: disruptive, ambitious technology insertion, and aggressive ramp-up of SAF and hydrogen. And a much less ambitious one, kind of business as usual one called Iceman. And the conclusion is based on Iceman. And the message is we are definitely working on Maverick. We are working on technologies, and we need those young people to come to deliver the next disruptive engine to the next generation of aircraft and to make it feasible. So that's the first thing. Second thing, it's about the carbon budget. It's the right question. And to be fair to the team, that what they did is they were unable to decide what to attribute to allocate to aviation. So they made a call just to keep to the current share of aviation in emissions. But the International Agency for Energy has a scenario for all sectors to reach the 2 degrees. And in this scenario, they have allocated the budget to various sectors, not based on the current situation, but based on who can decarbonize earlier, where is it easier. And some sectors are easier to decarbonize, and that's where we should act very, very aggressively now. And for aviation, we are working aggressively, but it will take a bit more time, so we need a bigger budget. At the end of the day, the total of the budget must be within what is feasible. But I challenge seriously the fact that aviation needs to be given its current share. It's really having an overall trajectory for all sectors that it makes sense.
Thank you. Do you want to add something, Paul?
What I would say to young people is that human innovation knows no bounds except the laws of physics. We put a man on the moon in under 10 years. The COVID vaccine race has been unbelievable. The world pulling together to do something that just would have been inconceivable a few years ago. And I guess what I feel about human ingenuity is between now and 2050, when we have to decarbonize aviation, and we will decarbonize aviation, those young people will grow up to be 30, 40-year-olds who will come up with new ideas that this generation hasn't thought of. we're already seeing some evidence of that. And in fact, I was looking at a young person's work on synthetic biology, new ways of capturing CO2 into plants that hadn't been thought of before. Just as one example, there's going to be so much innovation. I'm very upbeat that aviation will benefit from innovation and will meet that challenge.
Thank you. So I want to thank all the panelists to have given confidence that industry research is committed to provide solutions in the future and to tackle the environmental issues. So thank you for your comments. Thank you for the details you gave on what you are preparing. Thank you once again. I'll leave the floor. I think there is a break of 5 minutes, and then Jean-Paul Hertemont will give a final conclusion of the day.